bring it up on networks because I think you always likely to get a question on networks. Do you understand what it is? Do you see what the GIS is trying to do and how it does it? How do you, let me ask all of you a question. You can put on your microphone and then you can answer it for your own self. Just answer it for yourself. If you were asked to build a network data set, which data acquisition method would you use? And what would you measure? If we're asked to build a network data set, if you were asked to build a network data set, which data acquisition method will you use? What will you measure? Okay, so it's a question, it's an interactive one section right now. Because you may not ask me a question, but I've asked you a question. Put on your mics and let me hear you. I know there are two of you at the moment, but yes, I would still love to hear from you. Yes. Answer it anyhow, please. Please put on your microphones if you can hear me and answer the question for me as part of my interactive section. Or you can't hear me. It means someone is not even listening to me. That's why they are still on. You see, people don't take part in the lecture, and then they go and score 2/30, and then they will say this lecture is wicked, though. Anyway, Israel, just give me your answer. I don't think I have time. These guys. Israel, your network is bad, eh?
Yes, sir.
Go ahead.
Hello.
Yes, go ahead, please. Go ahead, please.
Yeah, hello. So I think I'll prefer the vector model.
No, so the vector model is not a data acquisition method. The data acquisition methods are surveying, GPS, remote sensing, photogrammetry. So you need to look at it, the notes very well, the way I've the slides and the way I've given it to you. Okay. So we have to group the topics. The answer here, the question here is an data acquisition method. How you get data is fundamentally you take a device, are you okay? And then you go to the ground and you measure. Are you okay? And so GPS is a device, whether it's in your phone or you are holding it, it's a device. So the question here is saying, how would you go about collecting data? So vector doesn't come in. Vector is when you are done, then you'll be able to tell, okay, what I'm holding in my hand is a vector data. Okay. Or the concept behind it is vector, but then the actual method should be something you can call remote sensing. This, are you okay? So that is where you are not getting it right. What would you be measuring anyway? If you use, so which one are you going to use? Remote sensing, photogrammetry, or which one of them?
Yeah, we're using remote sensing.
Okay, go ahead. That answer is not good, though. This answer will not get you any mark. You just use remote sensing to do what? Do you understand how it works?
The remote sensing.
Talk to me, Israel. I want to understand. I want to get to know what you are thinking so that I can clarify. Go ahead. Can you hear me when I talk? No, I don't think this guy can hear me. Anyway, that's fine.
Hello.
You can't hear me when I talk. All this while, you can't hear me when I talk. Oh, yeah, Simon. Okay, let's carry on. Let's carry on. So all this talking plenty I'm doing now, you can hear.
Hello.
Israel, your network is bad. Fix it. Is that okay? Fix your network. Oh. Anyway, let me carry on because I don't think this is frustrating and I have to move on. Okay, so it was time for you to ask questions and your network is bad. You can't ask any questions. So I'll move on. So the next thing that I want to talk about is 3D analysis and surface rendering. It's very important for us to know that data is not only collected in planimetry. In other words, we just don't take data and look at it like if everything is flat. Okay. But then there is the elevation or height component, which is actually very, very useful in doing a whole lot of analysis, like hydrography. Are you okay? You can do it's a hydrography, hydrology. Are you okay? Can talk about hydrological analysis, in which you want to know flow of water and a whole lot. Are you okay? What we call watershed. Are you okay?
A whole lot.
Etc. Okay, so we are going to talk about what we call viewshed, and of course, viewshed and watershed are going to be the same. So in a viewshed is really an area that is visible from a specific location. Viewshed is an area which is visible, okay, from a specific location. So wherever you are, you always having a viewshed. So you can see that this has some security implications. So when you have security guards in a church, in an organization, and you want to see their effectiveness, try and look at their viewshed. You easily solve a big problem. And people wonder how you did it. Are you okay? Because their viewshed is where the thief doesn't want to be, or someone trying to sneak in always goes outside the viewshed of the security. So this is like a very interesting one, very, very interesting one. So the analysis for viewshed makes use of a digital elevation model or a DEM. It's okay. It's a lecture. So when I write DEM and I mention the meaning and you are hearing it for the first time, write it down. So DEM stands for digital elevation model. Is that okay? So digital elevation model. All right. So DM. Someone said them. I don't know. Yes. So we can use the viewshed analysis to locate communication masts, for example. So the idea is that where the communication mast is, the signal can reach certain places. So the areas that these signals can reach then become the viewshed. And what does it mean? Where signals can reach, we can also say you can get reception. If your phone is not a YAM or like it's not a bad one, then you can get reception. So in locating communication masts, one of the things that should ideally be done is a viewshed analysis, except if they don't care about the customers, because there are places where signals don't reach in the city, which is really sad. Okay. All right. We can also obtain a view from a road. That is also possible. So what can we see as we move on a road? I mean, seriously, you can use, depending on what you want to do, you can use a viewshed for a whole lot. So instead of you doing a viewshed, you can actually do a watershed. So where can water reach, for example? Okay. And so I want to actually explain to you how the viewshed works. And then we can continue. Where's my whiteboard? Okay, there you go. Okay, so this is how the viewshed works, usually your data set is a digital elevation model. This is how a digital elevation model looks like. It's a picture. Are you okay? It's a picture, but then in this picture, you don't see a human being or something like that. It's actually a picture that contains values of elevation. That's all. Let me just put it that way. So it's a matrix of elevation values. All right, so we can have 2, 3, 4, 7, 10, 1, 2, 3, 13. Intentionally, I'm putting values that are low, values that are high on purpose. Okay, so this is a digital elevation model. You see it will look like a picture. Are you okay? But then you wonder what it is, just colors. And the color values can be matched to the elevation at that place. Are you okay? Okay, so here you can see that the heights here are the same. When you travel here, you won't go up or down. Are you okay? And then you can also see that this point here is blocking this one. Okay. Obviously, because it's an elevation model, so it means that you are seeing places that are going high. It's an undulating surface. So this is a surface. That is why we're talking about 3D surface renderings and viewshed analysis. Okay, so we can render a surface. Okay, so this is a surface. Okay, obviously we can determine where we are via the column and then the row numbers. Are you okay? And then the row numbers. So yes, this is a raster something. Are you okay? Raster model. So the DM is a raster model. All right. So in a viewshed, all we are doing is that, okay, if I'm at 1, can I see 15? So that's a question. Israel cannot hear me, but you should be answering this question. Okay, or anybody watching this video, ask yourself the question: if you're at 1, can you see 15? No, you can't. Okay, and the reason you can't is because it's blocked by 11. So 15 is not in your viewshed. 11 is in your viewshed. Well, it's blocked actually. And 2, 1 is also blocking it. So virtually you end up not seeing beyond this area. You will see beyond this area. You just be your view will be limited to the sides of this. Okay, so if this is a mountain, then obviously you're looking at the sides of the mountain. Okay, so this is the idea of the digital elevation model and its use in viewshed analysis. Okay, so you can always mark areas that are visible. Let's look at something like 13. What's the viewshed of 13? 13 will see all these areas. You see here, see there, because the value there is higher. So the viewshed from 13 are these points. Are you okay? Except it cannot look beyond 15. So we'll be missing 11 and all that. Are you okay? Okay, but probably, okay, you may not see 5. Are you okay? So this is the viewshed. So if you were doing an analysis, then you know where you are heading towards. All right. So back to our slide. So viewshed can be calculated using an individual point such as a tower or multiple points such as a line representing a road. Are you okay? And you say, okay, if I'm on this road, what are the areas that can be seen? So these have security implications. I'll always say that. And also for locating certain devices. Okay. The military will need it. You can see that. Okay. So the algorithm that estimates the difference of elevation from one cell to the other, to the next, each cell between the viewpoint cell and the target cell. Are you okay? And normally we want to, that viewsheds are also, that process, are you okay, it's also known as the line of sight analysis. So viewshed analysis is also known as what? Line of sight analysis. Okay. So you can use viewsheds in so many interesting ways. Like I said, in telecommunication, you can use it. You can also use it for security application. Okay. So that is it. Basically, you don't need to know any more than that. Okay, just appreciate that there are parameters that need to be plugged into a software, and then once those parameters are plugged in, then we'll be in a position to now compute, but the result is a picture. We are going to get a picture. Are you okay? We are going to get a picture. So one of the parameters that we need, or a couple of parameters that we need, is what I'm going to show you. Okay, so here you can see that we have an offset from the target. Offset 2, offset 1 is the offset, the target itself, where the signal is being transmitted. If it's a human being, then we are talking about the eyes. Okay, your height. Okay, the height of your eyes above the ground, that will be offset 1. Offset 2 will be whatever you are looking at. Okay, how elevated it is from the datum. Is that okay? So datum, the word datum, I think we touched on that in map projection. I hope you followed it. So we can talk about the azimuth. Okay, so azimuth 1, azimuth 2 would also limit our viewing angle. Okay, sometimes you can see a certain range. From a certain range, you cannot see, everywhere. And so you can have offsets, azimuths. You can talk about vertical angles. Okay, for example, you can look as high as a certain points, but you can't look beyond. Are you okay? So that one will be the vertical. So V1 is the vertical angle. V2 will be another limiting, angle that we can actually use. So putting together all of this, you can also talk about the radius. Radius 1, radius 2. Sometimes you can be living right under a transmitter, but you will not be getting signals. That's the reason for R1. Are you okay? So that people there can also get signal. Because the transmitter is transmitting far away from you at a certain distance. You are sitting right under it, MTN tower, and you're not getting MTN signal. It's possible. It's all right. So when you're done, then all you do is to just delineate the areas which are visible based on the parameters. That's all for viewshed analysis. The same thing can be done, a similar thing can be done with your watershed. So you can imagine watershed areas where water can reach when it's raining, for example. So you can look at the elevation values. All high elevations, they say water find what its own way is one of them, but there's another one. It says water goes to it settles at the lowest point. Okay, so that principle can also be used in a watershed. So you get to know that if it rains for 2 minutes, these are the areas that are going to be inundated, okay, or covered with rain. Is that okay? All right. So viewsheds are interesting. They are implemented in a couple of software. Cells of higher, where is it? Value are between viewpoint and target cells. Okay. Cells of higher value are between the viewpoint and target cells. The line of sight is blocked if you have that situation. Okay. And they cannot be part of the viewshed. Take note of that. You need to discuss some of these topics to really appreciate it. Some of you, we don't discuss anything. All right. I think I've talked about the vertical angle, which limits it. Okay. Next topic is visualization. Okay, because now I can't hear any of you, so no questions are coming through. Visualization talks about.
So I wanted to speak something.
Okay, go ahead. Go ahead.
Yeah, with the digital evaluation model.
Elevation model. Digital elevation model. Write down when you are listening. You are in a lecture. Write down, because you can't say digital evaluation. No, you can't say that. That's not what I said. Digital elevation. I even typed it. Elevation model. So you write it.
Yes.
You say the right thing. Okay, go ahead. Sir. Right.
Yeah, digital elevation model.
Yes.
I'm using that one. I'm using that one for my project work.
Okay, that's good. Good to know that.
Yes, assessing the flood-prone areas in Ewutu-Senya, that's the whole of Kaswa, using the digital elevation model.
Okay, that's good. That's very good.
I wanted to assess those that are highly prone, moderately prone, and less prone areas.
Okay, that's fine.
But so I wanted to know more on that.
Yeah, I think I've just discussed that. Did you hear me?
Yes, I heard you.
Yeah, so do you think you understand what I talked about?
Yeah, but with the example you used, considering the chart, the one that looked like the vector, the chart, the box. I wanted
that one is raster. That one is raster. That one is raster. That one is raster. What you are looking on the board right now is raster. You see, vector looks like this. Vector is like. So, let me show you. Vector. This is vector. Vector. You see lines. You see polygons. So this is what you are looking at here. Is this is vector. When you see raster, a raster will be a picture, an image. Are you okay?
Yes, sir.
Raster is going to be an image.
Yes,
Take note of that.
So yes, sir. So, sir, when
but then in every image, the image is made up of small squares, especially digital, images are made up of small squares. Okay.
Yes, sir.
So even though you are seeing a picture, let me show you something. I just want you to, when you look at these two, are you seeing this image I'm showing?
Yes, please.
So you see that what I'm showing you on the left-hand side is actually this I'm talking about. But just that I'm using the numbers to explain to you why are you getting how this is the composition of what you are seeing on the right-hand side. So you see, don't miss vector and raster. In the vector representation of elevation is via spot height. Have you heard of spot height?
Yes, please.
Spot height is what you find on a map, site plan, those things, engineering drawing. You can you are working on the project. So that one is vector. Okay. Here on the left-hand side, I'm not showing you polygons. I'm showing you a raster model, but I'm just showing the concept in theory. But in reality, what you get is what I'm showing you right now. This one, this image you are seeing here in this area. Okay, so this is what you will get in your hand. But now, when you actually get it into software, then you can manipulate it. Are you okay? The software will now see these values, and then the algorithm will now start figuring out. Why am I getting an echo? Is it from my end or from your end? I'm getting an echo, a feedback. Okay, I think it's from your end. All right, so this is it. You realize that the rest is using the software to load it. Understand the concept? You have to load an image like this one. These two, the grayish one and then the pinkish one. You load it and then use the software to now compute areas that are like this or like that. So there are steps that you have to go through. Are you okay? So you have to, if you have any further question on how to get it done, that will be outside this one. Because what we are talking about here, yes, in the watershed case, for example, in the watershed situation, is that when water falls in this particular DM, this one, if water falls, where would it accumulate? If we ask you to do it, an analysis on that, It's assumed that when water falls, the same amount of water falls on all the cells. But some of the cells, the lowest cells will keep the water and start building first after it's seeped down. So you need to consider the ground, whether the ground is paved or it's not paved. Are you okay? If it's paved, then water will get absorbed. So you create different layers. Practically in GIS, what you do is that you combine several layers. Are you okay? And then you now find out the most suitable, like areas where it is prone, like water is likely to like accumulate. Okay, and it has to be based on the surface. You have to get data on the surface itself. Then you need to get elevation data as well. Then you need to get data on drainage in the area as well. You need to take all these data and then cost them. Okay, so the areas with the least cost will now become, or the highest cost will become the areas that are prone. Are you okay? Israel, are you okay?
Yes, please. Yes, please.
So you
Yes, please.
have to combine different layers and then cost them. You create what we call a cost surface. Is that okay? And then you now combine it, add them up. You use the raster calculator to do that. Anyway, so we have to do a practical one. This one, it's not a matter of talking about it. It has to be done. And then maybe because of your projects, we'll see if you can do something like that during the practical. I'll show you something on the cost estimation. All right, so let's move on. I was going to talk about, yes, go ahead. Yes, go ahead.
With a position of 13, looking at the elevations there.
Yes.
I think first I wanted to know, can a person see beyond the boundary of 1?
From 13?
On the left-hand side.
Okay, so your question is that, can they see beyond this place like this? From here? Is that your question? Can a person see in this direction? Is that what you are saying?
Yes.
But we don't know what is there. So that is why the data you have limits your analysis.
Yes.
So
please.
it's assumed that this is the data we have. So we'll be limited to this. So if you want to do more analysis, you have to.
Or the boundary avoids that.
Exactly. So you have to now go and buy another data set from European Union or whatever, and then do the analysis here as well. Are you okay? So here I've gone to buy more data so I can extend my analysis. So it depends on the extent. Are you okay? It depends on the extent of your data coverage. Okay, so that is that. It's assumed that you can see beyond that, but obviously we don't know what's there. So your ability, sometimes you can live in a country in which you don't know. I mean, in Kumasi, where my parents are living now, I looked on a map and I discovered that there's a lake. But you see, when you actually walk in the area, you never know there's a lake very close to you. So the data you have, determines the power. The information is power. Are you with me? There's a funny movie or an excerpt from a movie in which a lady who is a princess or a queen or something, like very powerful woman, and she was talking to a certain man who seemed to be like very intelligent, or I don't know who he is, but the gentleman tells the lady that knowledge is power. Immediately she says knowledge is power. The lady instructs her soldiers to kill him. So they put the knife to his neck, and then he actually tells them that no, don't kill him. Then he tells the guy, power is power. Okay. So knowledge is power, but obviously power is power. And we have 10 minutes. Let me talk about visualization. So I think you've understood this, right? Have you understood it well, Israel?
Yes, please. Yes,
So
yes, please. I'm
I
okay.
want you to know that I'm talking about the picture on the right. This is how in reality you get this image. Meanwhile, on the left-hand side, you get what? It's an explanation in the classroom to explain to you. This one here is actually this one being explained. This is theory. On the right-hand side is practical, what you get you put in the software. Okay, great. So that's why you need to do some practical. I'll show you how a DM look like very soon. I think I'll show you. All right, let's move on. And let me talk a little bit about visualization. Visualization is about really looking at, you can look at 2D visualization, 3D visualization, but I want to just emphasize that 3D visualization is very important. In mining areas, drill holes, that they do drill holes into the ground. They have a rig that goes to dig it. So in fact, if you have an ore, for example, then you have to show it in 3 dimensions, visualize it in 3 dimensions. I want to just bring your attention to that. I want you to also know that the brain actually likes pictures. Okay, 50% of the brain's neurons are involved in vision. So if you want to actually show something, that's why women always fall for. Okay, people who kind of wear the right trousers and then they dress up very nicely. And then after the marriage, then they divorce the guy because everything the guy has in the room is actually for his friend. Okay, that's because what the woman saw is what she went in for. And women's brain, we all know, it's that powerful. I'm not being a sexist here, just to explain stuff to you. Considering the cartographic complexity of the terrain, it's always better to look at things in 3D, visualize it very well. Otherwise, you will be getting the wrong impression. 2-dimension will deceive you. I always give this example that if someone came to you and told you that all the the mineral that you have in your country is like this, that's a big lie because that's 2-dimensional. Are you okay? This is true that there's a lot that's being hidden from you. It could be that it's as long as this. Are you okay? Or it could be that it's actually that little. Are you okay? So 3D visualization is very important, and then it's very important to show things into the 3-dimensional visualization of things are actually created by psychological cues. Sometimes it's just colors that are used. Okay, you can see something 3D, but then you can't really touch it. Are you with me? So it's just a perception. We add attenuation, atmospheric attenuation, texture, and all these to it. There's something called virtual reality. As if you are within a certain space. Okay, it's used for training pilots and all that. So that is the importance of visualization. I just wanted you to appreciate it, that there is something like that. Please don't worry yourself too much about it. No calculation. In GIS software, they make use of axing, which can let you see a building in 3 dimensions, like the same way we see it in AutoCAD. And then also in QGIS, there's NVs or something like that plugin in there in QGIS software that allows you to do that. Okay, now guys, install QGIS software. As I told you to do that, I'll give you data and do some practical. Okay, so 2D, we can use 2D to show some areas, but 3D can show you the actual, solid. You see the thing like a solid. Okay, and you can also drip it. You can also cover that solid with some kind of 2D, all right, presentation. So it's like showing the undulations in, I'll use Kumasi because Kumasi has an undulating terrain, and then dripping Kumasi with, say, the election results, then you realize that you'll be having an interesting visualization, all right? It's possible because today, the computers that we have are very powerful and they are very good for displaying a whole lot of stuff. Are you okay? The computers that we have today are very powerful and they can showing 3D is very easy. Some of the flash screen TVs that we are using, digital flash screens, they are really like, they can allow you to do a whole lot than you can imagine. And it's all part of visualization. So there's been great improvement in graphics, computer graphics, that should allow us to display things in an interesting way. Okay, so that is it. There's a very small topic there, yeah, for you. All right, so what is the next one? I think the very last one will be more on surfaces. I want to talk more about surfaces. and then we'll be done. So let's take your questions. You have 4 minutes for this session to end. I'll take your questions. Any question at all? Ask questions that are interesting. We are in university. Is that okay? So I want university level questions. No, what I really mean is that ask questions. Go ahead. Any question at all is fine. On what I'm talking about, what I've talked about today. I've talked about network analysis, and I've talked about 3D analysis and surface renderings, viewshed analysis. Okay, so this is an introductory something to actual surface. We're talking about surfaces, what really constitutes a surface. We talk about that. Okay, so there's more to this topic here. We are seeing. If you don't have any question, then I think I'll be ending it. If you have a question, ask. If you don't, I think we're saying goodbye to each other. Okay. Can I ask a question on other things I've talked about previously? All right, guys. So thanks so much for the attention. When is exam? I don't know, but let's all be preparing for exam. As I teach, take note that I'll be asking you questions as we go. All right. So take care of yourself, and we'll meet same time next week. Is all right? God willing. Have a blessed week. Bye-bye.
Okay. Thank you, sir.
Welcome.
Bye, sir. God bless you.